Sound design.
So how do I know if my main and sub are phase aligned? And if I turn them on together, they're going to work well together? The easy way to verify this is just to see if through the crossover region, they are within 60 degrees. As long as the main and the sub are within 60 degrees in their phase trace through the crossover region, you will get summation. So with matched speakers that come out of the box meant to work together, you shouldn't have to do anything, right? So this may be an easy process where you just measure both, verify that they are aligned through the crossover region, and you're done. So in this video, I just want to show you how to identify that situation and make sure that you're okay. So since this is the first time I'm doing this, I want to make it super simple on myself. So what I'm going to do is I'm going to put the speakers on the ground and right next to each other. So let me show you the setup. All right, so here's my two speakers. I've got them on the ground. I've got my sub here. I've got my main here. And then in between them, I've got the microphone. And I decided to do it that way because I've got the center of the sub here, the center of the main here, and then equidistant between the drivers here, right in the center, I put my microphone. Now with the subs on the ground like this is going to give me improved signal-to-noise ratio and avoid other noise problems and reflections and stuff like that. So this is a great place to start for doing this kind of comparison, especially since this is my first time. All right, so let's take a look. We're going to measure the main, we're going to measure the sub, figure out where the crossover region is, and then see if they're phase aligned. So I'll start at my measurement, turn on my signal generator, make sure that I'm looking at the main. And the first thing I'm going to do here before I do anything else or zoom in is I'm just going to make sure that these are matched and level to hit my target trace. If you don't know how to make your own target trace in Smart, I did another video about that and I'll put a link to it below this one. All right, so this looks pretty good. Obviously we have to ignore all of this because the microphone is right in front of the low frequency driver. So I'm just using this information down here to make sure that I am at the right level. Cool, so that looks good for the main level. I'm going to do the same thing with the sub, but while I'm here, let me stop talking and I'll save this trace. Okay, switching over to the sub. And looks like we're at about the right level, okay? You'll notice that I made this adjustment already before. I think I started at something like -20, and that was a little bit too low. So then I just slowly brought it up until I hit that target. All right, so now here's my question. If I turn these both on together, main and sub, am I going to hit this target curve? Am I going to get summation where they have some interaction together? So before doing anything, let me just do that real quick and see what happens. Okay, we are not hitting our target curve. And since I ran through this already, I can show you what might be an improvement. So I'll put in this delay and let's zoom in. All right, take a look at this area here and I'll hide our pre one. So here's main plus sub together pre. And here is the delay that I added later after I did some tests. And you can see that after I stop talking, you'll see that before we did not have the summation that we deserve in this area, and now we do. So this is why you want to check this stuff out ahead of time to see how these speakers work together natively. When I added the delay, it looks like I got as much as 6 dB extra summation through the crossover region, and I could even hear it here. It sounded better. Okay, so let's talk about how I did this. I'm going to hide these. And let's go back to our main and sub pre. So my first question is, what is the crossover region? Well, I know the crossover region is the area where the main and the sub shake hands and they sort of hand off information. Okay, now you take the low end. Okay, I'll take the high end. But where exactly is that? Like, at what frequency? Well, I know that anywhere where two sources interact that are within 10 decibels from each other, they could have an effect on each other, even if it's just 1 dB of summation or cancellation. So I think the easy way to look at this is to offset the trace by 10 decibels and see what the point of interaction is. Switch to my main trace, and I'm going to offset it by 10 dB. I'm going to look at that frequency. Could be any one of these. Okay, let's go with 80. Now let's go in the other direction, minus 10. That one's easier to see, 125. So our crossover region is 80 hertz to 125 hertz. So I need to be within 60 degrees between those. So let's zoom in and make this really easy. So from 80 to 125. Here's 80. So I'll just right click and go up to 125. And I'll rotate this around to make it a little bit easier to look at. So each of these gray horizontal lines that you see is 30 degrees. So as long as we're within two of those lines, we're within 60 degrees. But I can also press the Z key and switch back and forth here. So let's take a look down here. Up here, I'm looking at these numbers. 200 degrees, 144. So 200 minus 144 is 56. So down here at the bottom, we're within 60 degrees. We should be okay. But I can see just visually that as we get up here around 90, we go from 104 to 170. Okay, so we're beyond 60 degrees. Now we're at 70 degrees of separation between these two phase traces. And up here, we're going to be even farther. So now I know my main and my sub are not phase aligned. Not through this crossover region with this setup. So just to recap, how do I know if my main and sub are phase aligned? Well, I set their levels to match my target trace, right? Then I figure out where the crossover region is by finding out where their amplitude traces are within 10 dB of each other. That's my crossover region. Then I'm going to look at the phase within that region and say, am I within 60 degrees? Because if I am, I'm good. If I'm not, which is in this case, then I'm going to need to do a little bit more work. So in the next video, I'm going to talk about how to fix this problem. Sound design.